All right, so like I mentioned, we're going to finish 7.6 today, but just to do a recap, make sure my stuff is straight. Hold on 1 second. You guys can see my notes okay, right? Anybody? Yes. Yeah,
Yes.
no? Okay, thank you. For some reason, it's doing something a little different. Zoom is, so I don't know what's going on with it. But all right, if you guys have any issues, just let me know. And then I'll try to reset or whatever. But if you looked at the video that I sent, I think it was on Friday, talked about finding the magnitude. If I have the magnitude of vector v, that's just going to be our distance formula. Yeah. So let me see. Oh yeah. All right, so you have vector v. Those double lines on each side is your magnitude. And that's x2 minus x1 squared plus y2 minus y1 squared. And you take the square root of that. And I guess I'll just throw anything up. Let's say if vector v had an initial point of 3, 2. Let's go 3, -2. And then terminal point of 4, 1. Just labeling my points, making sure we're all right. So we have 3, -2, and 4, 1. And we want to find the magnitude of this vector that has the initial point P, terminal point Q. I'm just going to go ahead and call it V. X2 is 1. X1 is -2. Make sure you don't lose a negative. Y2 is 4. And then Y1 is 3. All right, so that's going to be 1 plus 2, which is 3 squared. 4 minus 3, which is 1 squared. 10 plus 1. I said 10 plus 1. Thinking ahead. 9 plus 1. And then the magnitude is square root of 10. And so, yep. Questions on that? So your magnitude is just the length of your vector. Vector is your directed segment. And you know all that was in that video. All right, let's say if vector v is equal to 7i plus 3j, and vector w is equal to 4i minus 5j. Find 6v minus 3w. All right, so we can represent our vectors in rectangular coordinates. That's what we have right here. The 7i plus 3j, 4i minus 5j. And whenever we want to add or subtract them, or even multiply to them with these scalars, 6 and 3 are considered scalars, just regular numbers, another word for regular numbers. You would do it the same way you would in algebra. It's really algebraic, in which you distribute 6 into your vector v, and then distribute -3 into vector w, then combine your like terms. So v is 7i plus 3j minus 3, 4i minus 5j. Distribute the 6, distribute -3, 42i, 18j minus 12i plus 15j. Combine your like terms. 42 and -12 is 30i. 18, 15 is 33. Let's see, anything else major before we... Oh, also, if it's in this form, you know, with the I and J components, if I wanted to find the magnitude of V using the same components, that V is equal to 7i plus 3j. If you have it already set up like this and it's not in your within your ordered pairs, you know, initial point and terminal point, then the magnitude is going to be a squared plus b squared, square root of that. So 7 squared plus 3 squared, 49 plus 9, that'll be 58. And yep, can't reduce that any. So that's all that would be. All right, so that's pretty much the foundation of what was done in that last video as far as calculation is concerned. And then there were other things you said, just letting you know what vectors are and all the stuff like that word-wise. So let's go ahead and look at the stuff that we didn't talk about in that section. This is a long title, but find the unit vector that has the same direction as a given non-zero vector v. So that's supposed to be the title. All right. All right, so for any non-zero vector v, v over the magnitude of v is going to be the unit vector that has the same direction as v. So to find that vector, we just divide v by its magnitude, which is what this is right here. All right. Remember we mentioned unit vector is a vector with the magnitude of 1. Okay, so find the unit vector in the same direction as v equal to 5i minus 12j. All right, so first, all right, so first thing we'll do is find the magnitude. So that's a squared plus b squared. And first part is a, second part is b. So 5 squared plus negative 12 squared. 25 plus 144. It's 169. Square root of 69 is 13. So the magnitude of V is 13. All right. So then we'll divide divide V by that magnitude. Or if you want to look at it this way, same thing. Minus 12J. And that should be it. So 5 over 13I minus 12 over 13J. All right. So the other thing I think, yeah, this is it. I could have put that in your video. All right. So next thing in here. All right. So writing a vector in terms of its magnitude and direction. All right, so the components A and B of a vector can be expressed in terms of the magnitude of V and the angle theta that V makes with the positive x-axis. So theta is called the direction angle of V. So the angle that theta makes, the angle that vector V makes with the positive x-axis is going to be a direction angle of V. So by definition, sine and cosine can be represented by this. Oh, see something in the chat that I moved too fast. Nope, you will not be able to escape theta. So cosine theta is equal to A over vector B. Sine theta is going to be equal to B over vector V. And so that also means that A is going to be equal to vector V cosine theta. B is going to be equal to vector V sine theta. So that means that AI plus BJ, going to be equal to, I don't have enough room. All right, so that's what we ultimately will be able to come along or come away with using those relationships. All right, so that final statement, a vector that represents the direction and speed of an object in motion is called a velocity vector. Mm-hmm. All right, so the wind is blowing at 20 miles per hour in the direction of north, 30 degrees northwest. Express the velocity as a vector in terms of I and J. All right. So when we look at theta, and I guess I could wrote the whole thing. And we're going northwest, 30 degrees. So this right here is going to be 30. Talking about northwest. And we're talking about theta actually starts from your positive x-axis. So that means theta goes from here to the northwest of 30 degrees. So that means theta is actually going to be 90 degrees plus 30 degrees, which is 120 degrees. And our velocity of our vector is going to be that 20 miles per hour, since the wind is blowing at 20 miles per hour, that will be our velocity, the magnitude of our velocity, excuse me, not the velocity, but the magnitude of our vector. Magnitude of our vector. All right, so we have our pieces. That's all we need because that's the magnitude of V, cosine theta I. Plus magnitude of V, sine theta J. So that'll be 20 cosine of 120. And then 20 sine 120. Cosine of 120, negative 1/2. And sine of 120, square root of 3 of 2. So 10 and 20 is 10, 20 and 10. 20 divided by 2 is 10, I should say. It's negative 10. And that's going to be plus 10 square root of 3j. And yeah, that's it. So, oh no. All right, hold on 1 second. All right. So that's just basically the wind's velocity in terms of I and J. All right, let's see what time we have. We get out of here. We can start 7.7. Look at the dot product. All right, so dot product, if we have A1I plus B1J, and for vector V, and then vector W, A sub 2I plus B2 or B sub 2J. They are our vectors. The dot product V dot W is defined as A sub 1 times A sub 2 plus B sub 1 times B sub 2. Not too bad, right? All right, so let's get an example. V is equal to 5I minus 2J. W is equal to negative 3I plus 4J. Tell us to find each. A is V dot W. All right, so I'm gonna take the, I guess I'll go red. Take A of V times A of W plus B of V times B of W. Negative 15 plus negative 8, negative 23. You know, we'll get to the application in a few, but as far as at its foundation, that's all you have to do. So if they ask you for the dot product of WV, try to stay consistent. You're looking at A of W times A of V plus B of W times B of V. And you see we get the same thing. Did it go there? Looking for something. Maybe I'll see it as we go forward. Okay, yeah, there you go. All right, so then V dot V, dot product of V to itself, we're looking at 5 times 5 plus negative 2 times negative 2, 25 plus 4, which is 29. All right, problems with dot product so far?
No.
Thank you, sir. All right, properties of the dot product. If u, v, and w are vectors and c is a scalar, then u dot v is the same thing as v dot u. We just saw that in the previous example. If you apply the dot product of u to v plus w, then that's u dot v plus u dot w. 0 dot v is just going to be 0. A vector, if you dot product, apply the dot product to a vector to itself. There you go. That's the same thing as the magnitude of that vector squared. And then c, don't forget, is a scalar. Scalar is just a regular number. C times u dot v is the same thing as c times u dot v, but you apply the dot product first. And then it's also the same as u dot cv. All right. Okay, so we'll do one more example and then we'll call it a day. That'd be a good place to stop. Just curious if this code also unlocks tunes to the Holy Grail. I wish. I think I would like to go on an adventure. I think it'd be cool. I always like Indiana Jones. Got some Contra players in here. All right. All right. So alternate formula for the dot product if v and w are two non-zero vectors and theta is the smallest non-negative angle between them. So you're talking about if you have your two vectors, theta will be in between. Then v dot w is also equal to the magnitude of v times the magnitude of w times cosine theta. right. So another one. All right, taking the same thing from what we just said as far as what V, W, and theta are. Cosine theta. All you're doing is taking that and solving it for that theta. And so that means theta is going to be equal to cosine inverse of V dot W over the magnitude of V times the magnitude of W. All right. So let's go ahead and do an example of that, and then we'll be good to go for today. All right, find the angle between vectors 3i minus 2j and negative I plus 4j. All right. So we can find this in pieces. We're trying to find this angle. We need a dot product of VW. We need the magnitude of V and the magnitude of W. So we can find all of them separately first before we actually put it in the formula. So dot product of V and W, we're going to do 3 times -1 plus -2 times 4. For your dot product, you take A from one vector times A from the second vector, and take B from one times B from the other. And that'll be -3 plus -6, which would be -9. And why did I do that? Y'all supposed to catch me on that. That was y'all fault. So 2 times 4 is actually 8, not 6. But if you add them together, that will help you get 6. But yeah, that actually gives us 11. All right. Then the vector, or the magnitude of vector V, going to square 3 plus square -2. Take the square root of that. That's 9 plus 4. Square root of 13. And then magnitude of W, excuse me. -1 squared, 4 squared, So 1 plus 16 square root of 17. So before we take all three pieces and put it into the formula, any questions?
No.
All right, so theta is going to be cosine inverse of negative 11 over square root of 13 times square root of 17. So throw that in your calculator. I guess we could multiply that together. That'd be negative 11 over square root of 221. Yeah, 221. And that will be approximately 137.7. Make sure your calculator is in degrees. All right, so like I said, that's a good place to stop. Questions on anything I've mentioned before we close out today? 7-7. So next class we'll close out 7-7, and we will look to 11 at some point. I guess sometime next week. And so what we'll do is, next Tuesday will be open for you guys to ask whatever questions you want to ask. Let me see. So that's the week before Thanksgiving. So not next week. Next week will be, we'll review and we'll get into chapter 11. The week following is Thanksgiving week. We will not have class. People use this for in real life. Oh, well, we have some applications for it. When we start talking about force and all that stuff like that. Now, regular people, I don't believe use this stuff, but yeah, so scientists and, if you want to calculate the force that is being applied to whatever it is you're doing and stuff like that. So we'll do a word problem or application on next class. But yep.
So you said for Thanksgiving week, Tuesday is no class as well?
No class unless you guys really want to have it. I mean, figure you guys can use the time to get with your families or figure out how to get to your families and all the good stuff like that. So yep, that week will be off.
Sounds good to me.
All right, glad to hear it. My birthday's on Thanksgiving, so I don't mind celebrating a little bit early. So yep.
Mine was on Thanksgiving last year.
Oh, okay, cool. Yeah. So it's always good to meet another turkey baby. So anybody else before we close? I'm gonna teach this to my family during Thanksgiving and they're gonna hate me. Yes, man. Spread the torture. So if everybody's good, I'm good. I will see you on next class, looking to finish out chapter 7. If you have any questions about anything, feel free to bring one that day, because I don't think the rest of chapter 7 will take up the whole class time. So we'll have a little time left over if you want to use it. If not, that's always good. That's all good as well. Outside of that, you guys have a great day, and I will see you on Thursday.
Thanks. See you.
All right. Thank you. Have a good one.